Hello, I'm Mike von Fair Repair. Long time no see. Sorry for that. Really sorry for that. So what happened to me? Well, this is not so easy and so fast to explain. There were a lot of things going on actually. I had to source a new server system for our home and business. And I'm still trying to get it running like I want. And I was on vacation with my family. My lovely wife and little daughter, 1 week, and it was really nice, it was relaxing, and I was really in need of that. So what else? Yeah, I was on site 1 week in Hamburg, Germany, but this is another story. I'm not really happy about what happened there, and yeah, no, don't let us talk about that. Maybe you noticed I've changed the name of this YouTube channel into Fair Repair EN. Because since German is my native language, of course, sooner or later, I had to create a channel and upload it there, 1-2 videos for the beginning. And yeah, this is the reason why it was so silent over the last weeks. But yeah, today is today, and we have a new device to repair. This is a laptop Schenker Key 15 E20, a really nice and expensive device. I'm pretty sure it will cost around 1,500 up to 2,000 euro or even more, depending on the hardware inside. It is not in the best shape anymore. One hinge cover is already missing. The second is not really okay anymore. I'll take it out for the moment. And it was already in a shop, or at least on a bench of a technician, because it got already some sort of diagnose. It was diagnosed a defective M controller. A pretty rare and expensive one. I think it comes around 30 euro here in Germany, or even more. No idea. And in addition, this is a thing which I can't understand, because if the M controller is dead, then the whole laptop is dead. So I don't understand how the technician even diagnosed a defective controller for the GPU. No idea. But we will open it now and see with what we deal here. But first, let's plug the charger, or in my case the power supply. 1 second. So here's my tip. I've already sourced the correct tip, and when I plug the charger, nothing happens. Dead. And when I press the power button, nothing happens. Dead, dead, dead. Nothing. So this device is dead, dead, dead. Which is actually a good thing, because the less it does, the more easier will be the diagnose. And with some luck, the repair too. So where is my screwdriver? Here. So let's remove all the screws here. Now, good. So this is the board. This is the M controller. Smells a bit weird, but the overall condition of the board looks okay. So let's start with some basics, because sometimes we forget about that and trust too much in to our own experience and into what was shared by others too. So let's have our own side, our own view of the situation. So we have resistance mode, we have ground here. No, we don't. Do we have ground here? Here we have ground. Good. So let's find the main power rail. Here, this could be the main power rail. We have, it's almost open line. Interesting. So here's ground and here's open line. So at least the main power rail is not the problem here. So then the M controller. No, let's start with other things. Let's start with all the power rails at the coils. So here's a big coil. No idea for what it is. Kilo ohms sounds okay. Here we have some coils. Kilo ohms. Here we have a coil. 10 ohms, but close to the GPU can be. So this looks like for battery. Yeah, 400. What is that? 120. This is probably for the memory. See, 120 directly measured on the memory. What else? What else? This can't be everything. What do we have here? 35. And here? 6. 6 is low, it's far away. 6 is far away from the CPU. 14. 6, okay, here we are clearly in the GPU section, in the CPU section. So here we have another point for the main power rail. Here's ground, here's the main power rail, exactly here. Ground. No way, I have to reverse the probes. Like that. Yeah. So, and when I come, where was it? Here? Yeah, this is clearly the main power rail. We have continuity here. Okay? So the main power rail is fine. So we have to move under the microscope. No idea about the pinout. But this here looks like a big track, and this could be actually the firmware for the M controller. Can be. So far away from the PCH. The PCH has its own flash storage, so this could be pin 8. Oh yeah, 17 ohms. And pin 4 was ground, yeah? Yeah. Pin 8 is a power rail. 17. So now let's move with ohms mode. So here, for example, yeah, this is continuity. Here, this is not. Where else? Here? No. But here. Yeah, the M controller is partially shorted to ground with 16 ohms, but what I don't like too is the low resistance here, which I assume is a supply for the PCH. And if this is shorted too, then there is no point to mess with the M controller. Let's check. Ooh. Nothing. Kilo ohms. kilo ohms. One ohm and the second side. Yeah. It's dead shorted. Here, 9 ohms to ground. 1 ohms to ground. So this PCH has shorts at least on 2 power rails. We need to identify the 3.3, the 1.8, the 1.05, AWS. This is AWS. This is definitely a chip from Silergy. 1 second. Yeah, as I remembered, this controller is actually configurable about its output. So from this one, maybe this is, I don't know, 1.8. Do we find a board number somewhere? Here. So this is a Clevo board, and for Clevo, where are schematics? At least usually. Found it, and this is so nice. At first glance, it looks like a normal manual. This is so genius here, with here removing the battery and I don't know, but here it becomes interesting. Here we have the actual schematics of this device. Here. So let's have a look for power. Where is power? Yeah, and here's the firmware. 1 second. Here. U47. Let's double check at the board, and it is called U47-2. Yeah, this is it, and the power rail at pin 8 is VDD free. So, and let's see whether the M controller gets the same VDD free, and it does here. It does VDD free at pin 20, 26, 50, 92, 114, 121, 127. Yeah, so M controller is definitely, at least the VDD free is definitely partial shorted to ground. This we know already. So what else? What else? Where is the power? Here. VDD 3, VDD 5. So let's see. So the coils are PL24 and PL20. And I just found the VDD 3. It's located here. And 17 ohms, all right. I'm pretty sure these shorted caps here are a 3.3 rail too, but a 3.3 rail which comes up later in the sequence. And yeah, unfortunately we can't figure out where is it going, because we never find the load switch nor something else which is supplied. So we will perform a trick. This is another laptop with the same PCH on board, and when I measure the third capacitor here, which is shorted on the second board, here I measure 24 kilo ohms. Okay, we can zoom in a bit like that. Yeah, so I would say let's plug the charger. Good. Let's plug the charger and now in voltage mode. And let's see, 1, 2, 3. Nothing. We need to power it on. Okay. No problem. When we will power it on, where is the power button? Here. Okay, it is on. It will of course won't show picture because no memory installed. So once again, the third capacitor, right? 3.4. Yeah, it is a 3.3 rail. So and that's the point. We have two different 3.3. We have two different 3.3 rails shorted. We have the 1.05 rail partial shorted, and this is the clue now. Now we can move on and inject. So let's start with the 1.05 supply. We probably won't achieve much here because it is only a partial short, but we will see. We will see. It will take some current for sure. So then we'll zoom out again. Yeah, like that. I make the thermal camera ready. We will need ground. We will need plus. Let's check. Yeah, good. And now we will inject directly here. And it takes 40 milliamps, which isn't really much. Here is the battery. Where is the PCH? Stays stone cold. Here's something. No. Yeah, nothing is really heating up here. Expected. So, but when I go to this, yeah, now it is more visible. Now it is more visible. This, my friends, and this is only 1 volt, only 1 volt. So I'm not exceeding something here. But once again, look at the heat spot. And gone. Once again. Shorted. I mean, we can also try another point. Where was it? Voltage mode, no, ohms mode. We can check, no, this is not. No. Here. This one, for example. So where I'm injecting the ground plane? Can be. No, this is ground. No. Now you can see. Yeah? Is dead. Dead, dead, dead. And unfortunately, it is not economical to continue here. This is the sad but true story here. I can replace a PCH. I did it before on some devices, but I failed too. Sometimes because of my insufficient tools, but often because of the replacement part itself, because it is more or less not possible to get a new PCH. So it was very likely at some point soldered already on a random mainboard, where we don't know whether something like boot guard or similar was enabled, and if so, then some fuses inside of the PCH were triggered, and this is irreversible. You cannot revert that. And from there, the PCH can work only at the same manufacturer, or even only at the same board number, depending on the configuration. So this is the story and the reason why we cannot continue. And good that we have, and very good that we have checked that, because otherwise we would have replaced the M controller and programmed it, and it would be for nothing, actually for nothing. That's it. So, sorry to not have a happy end for you today. Maybe next time. However, thank you for watching. If you like my videos, I'm happy if you leave a like, a comment, or even subscribe to my channel. The tools I use are linked in the video description. Thank you for watching and see you next time. Bye.